This is the 3.11 Linear Applications Day 1 Notes video. So what we're going to do in this video is talk about some of the ways that we can see linear applications, so linear equations, in real life context. So let's start with example number 1. So we have Erica. Erica is driving at a constant rate, and she travels 30 miles per half hour. So 30 miles per half hour. Part A wants us to graph this situation. Okay, so let's think about this here. We're going to travel, or Erica's going to travel 30 miles. So 10, 20, 30, 40, each one of these is actually worth 20. So she's going to travel 30 miles every half hour. So if we look at our scale, that's a half hour. And our scale here on the y-axis is going up by 20s. So when we look at 30 miles per half hour, that point is going to fall right there. Another way that you could think about it is if it's 30 miles per half hour, that would mean for 1 hour, it would be 60 minutes or 60 miles. So 1 hour would be 60. We can keep with this pattern. Maybe we want to graph a few more points. So if 1 hour is the same as 60 miles, that would mean that 2 hours would be double that at 120 miles. So let's plot that point. So 2 hours would be 120 miles. Another thing that we should think about is what happens if she doesn't travel any miles per hour. Well, she's not going to travel any miles. Now we have our points. We can connect them. And notice how I'm going to put an arrow on the end. I'm not going to put it on the beginning part of the line because it wouldn't make sense to go negative hours or negative miles. Then part B says write an equation that models the relationship between the distance d, so that's our y value, and our x value is t. All right, well, we've talked about this in the past, that we need y equals mx plus b forms. That usually works pretty well for us. We don't always have to use this, but it works really well. Well, we just said that the y value is d, so that's easy for us. Our m is our slope, so let's quickly find that. Our slope is rise over run. So up 60 to the right 1. So 60 over 1 is just 60, which is our slope. So d is equal to 60, and it's usually x, but our x value here is t, and our y-intercept is 0. So I could put plus 0, or just leave it. Okay, now if we wanted to make sure that we are accurate, what we could do is in our calculators, in our function, we could create a new graph, and then graph 60t. In this case, we'd have to type in 60x, hit enter, and it looks like a straight up and down line, but that's just because our scale is only up to 6, and here that's going up to 200. So if we wanted to look at it a little better, we can change that to 200. But I'm more interested in looking at the table of values and seeing the point 0, 0, 160, to 120, and so on and so forth. So we're looking at the correct equation. Okay, number 2. So Jackson is starting an exercise program, and the first day he's going to spend 30 minutes on the treadmill and will increase his treadmill time by 2 minutes every day. All right, so we're starting on day 1 with 30 minutes and increasing 2 minutes each day. They gave us our x and y values here, so let's create a table of values to really see what's happening here. So d is the day, and t of d is our y value, which is the time. So day versus time. So they said the first day he spends 30 minutes. The second day, it's going to increase by 2 minutes, so 32. 3 minutes, 34, 4 minutes, 36. You get the picture. Well, it's saying we need to write an equation. So again, let's set it up. You know the drill. Y equals mx plus b. Our y is t of d. Our slope, well, we were just calculating that. That's 2 minutes every 1 day. So 2 divided by 1 is just 2. Our x value is d, so we're going to be careful to use our correct variable. And our y-intercept is not in our table yet, so let's find it. Let's work backwards. 1, if we take away 1 is 0. 30, if we take away 2, is 28, because we're just going in the opposite direction, so we have to use the opposite sign. So this would be 2d plus 28. Then in this part, it says find t of 6, the amount of minutes he will spend on the treadmill on day 6. So let's use our equation. T of 6 is equal to 2 times 6 plus 28. So T of 6 is going to equal 12 plus 28. Which is 40 minutes. And if we continue with our table up here with days 5 and 6, we're going to see if we keep adding 2 every time that this is also in line. Now, here's the catch. If you were not being careful and you put in your table 0, 30, your y-intercept would have been off by 2, and you would have had 2d plus 30, which would have made this part here off by 2 minutes as well. So always be careful and always try to find the y-intercept and slope if the equation is not as easy to find, like what we'll probably see in the next day. We're going to see different forms of equations that makes it a little bit easier for us to find equations, but slope-intercept form is very helpful for these two questions. So make a table.